Hello students, welcome to the next lecture on the numerical analysis. Today we will discuss about concepts about the fixed point equation methods. What is the inside of this fixed point equation method and how it works. So basically we will describe any of the root finding equation. F of x is 0. We transform this equation into here. Then we will apply some condition on the gx and finally we can find its bound. Myself, Dr. Harish Garg, we will explain all these concepts in the detail. You can simply follow my YouTube channel, Dr. Harish Garg, where you can find the various lectures on this numerical analysis. So far, we have discussed the bisection method, Regula-Falsi, secant methods. All these methods are used for finding the root of the equation f of x is 0. But remember, all these methods will require the intermediate value theorem. What is the intermediate value theorem is? You have to find the interval a comma b such that the function value at the point a and the function value at the point b, when you product them, it will be of less than 0. That means the f of a and f of b are of opposite sign. Once this property will hold, then only these three methods are applicable. Or you can see there is always a require of the interval in which root lies. On the other hand, we will describe in this lecture the fixed point equation method, which does not require these conditions, while it requires only the initial approximation, let's say x0. Based on this x0, we will find the x1, x2 and so on until we will get the convergence of the solution. So since the method is suggested you the fixed point, what is a fixed point firstly? So what is a fixed point is any point x is said to be the fixed point of the function g if g of x is equal to x. Or what is the meaning of that? If you draw the graph of say this is a graph of the gx, y is equal to gx, and if you draw the line of y is equal to x, this is a line of y is equal to x, this is a graph of y is equal to gx, then the point of the intersection is called as the fixed point. The fixed point means the point of intersection of the function g of x and the line y is equal to x. So this point and this point are called as the fixed point of this graph y is equal to gx. Remember, fixed point may or may not be unique. Fixed point may or may not be unique. There are so many examples like here. So 10x, there are infinitely many fixed points are there. So you can see if you look about this graph, these are the graph of the 10x, and if you draw the line of y is equal to x, so 1.2.3, 4 and similarly 5 and so on, there are the infinitely many fixed points are there. On the other hand, if you consider the function g of x is here, which is nothing but my parabola, fine, which you can written as y square is 2 plus x, then clearly says x is equal to 2 is the fixed point. Why? Because the fixed point is x is equal to g of x. So g of x is my 2 plus x. Clearly says when you substitute x is equal to 2, the answer will be 2 is equal to 2. So that means 2 is the fixed point of this function g of x. On the other hand, if you consider about the g of x is x plus 1, so what is the graph of this? This is the graph of y is equal to x plus 1. So if you draw the graph of y is equal to x, so this is a graph of the y is equal to x, which is a parallel line which can never intersect, so hence it has no fixed point. On the other hand, you can also find the value of the fixed point is by using here what is the gx is x plus 1. What is the meaning of that? X will be cancelled out, 0 is equal to 1, which is not possible, hence there is no fixed point. Based on this concept of the fixed point, we will explain you the fixed point equation method. The purpose of this lecture is we will learn how we can find the root of this f of x is 0 by using fixed point equation method. So we already described the bisection, Regula-Falsi and the secant method. The purpose of the same, we have to find the root. But right now we are finding the root by using the concept of the fixed point. What is the fixed point equation is? We have to look at that this equation is nothing but x is equal to g of x. So we can write in terms of the equation, which is xn plus 1 is g of xn. So once you know the initial guess x0, then this equation will give you the root finding of this. For example, if you know the bisection method, we can find the iteration scheme as a plus b over 2. When you are looking about the Regula-Falsi, then we are finding the root of the equation as a f of b minus b f of a divided by fb minus fa. Now in this case we have to use this iterative formula. Now once you are dealing with root finding of the equation, the purpose of this, we can transform this equation into the fixed point. We can rewrite the equation of this. For example, if you have the equation of this, fine, then clearly says I can write this equation as of this, or I can write this equation in terms of this also, x plus x square minus 2. Also you can write this equation in terms of this also, fine. All you can see, which is all the equations are nothing but x square minus 2, fine. So it means this is my gx, which is of the form x is equal to gx. This is also x is equal to gx. This is also x is equal to gx. So it means there are many ways you can write the equation x is equal to gx from f of x is 0. So the question arises is how we can choose the value of the gx. Another example is here. You can see, you can find the value of the x easily from this, like x square is 2 minus x square. So your x will be root of 2 minus x cube. Also we can find the value of the x from here. So once you are using this equation, so it will be 2 minus of this. Also you can use both the equations. I can return this equation as x square is common, 1 plus x is equal to 2. So x I can return this as root of 2 divided by 1 plus x. So you can see corresponding to this there are the 3 different forms. Moreover, if you look at the another example here, which is again of the different form. So the question definitely arises is how we can choose the value of the gx, or what criteria you can choose, so that what criteria you can choose for finding the value of the gx so that it converges to the root of the equation. For example here, if I choose this gx, does it, you can clearly say is root 3 is my root of this equation, fine. So if I take g of x is my x square plus x minus 3, does it converges to the root 3? Or if I take 3 over x, does it converges to the root 3? Or if I take this, does it converges to the root 3? How we can check whether they are converges to the root or not? That's the process is very simple. We can simply take the initial value x0. You can take as a 4.5, you can take as a 3.3, you can take as a 0.3, you can take as a 0.1, you may take as a 100. So you can choose x0 as per your own convenience. Based on this x0, we can find the value of the x1 by using here. Then we can find the value of the x2 by using here. That is in general we can say the iterative, that is a fixed point scheme is my this one. Once we are using here, we can find the third scheme, that is x2. x4 is g of x3 and so on. So based on this, that is we are defining the sequence xn based on the initial point x0. So that means we are defining here. Now the major question arises is again how we can choose the value of the gx. So clearly says now this is the sequence, because once you know x0 is say 4.5, then you will get the x1 is something, you will get x2 as a new value, and from here x3 as a new value, and so on. So these are my sequences. So the question arises is, does this sequence converges? That's a major question arises, and we all knows whether the sequence converges for all. We are not sure about that. So the sequence may or may not be the converges. So remember, if you have the sequence xn, what is the definition of the convergence is? When you take the limit as n approaches, it will be L, and that L must be existence and unique. Once this property is satisfied, then you can say it is a convergent, but it is not always true. Like if you consider the sequence of 0, 1, 0, 1, 0, 1 and so on, or 1, minus 1, 1, minus 1 and so on. So what is the limit of this? In this case, either the plus 1 or minus 1, which is not unique. So if the sequence is convergent to the alpha, remember, if the sequence, if I say xn plus 1 is converges to the alpha, then alpha is the root of the fixed point result. Or you can see this is the root of f of x is 0. So that means you can say alpha is the root of f of x is 0, and that is our target. So we are using the fixed point, we are finding the fixed point root, and that is equivalent to the f of x is 0. We will prove in the couple of slides how we can say alpha is the root of this one. Now look at that. If I look at the previous continuous example, whether this is my gx, if you compare this equation with the help of here, then this is my gx, either this is my gx or this is my gx. So which one we can choose? Either I can choose gx from here, or from this, or from this. The only condition is we will check whether it is convergent or not. So how we can check the convergent? We can simply take the initial point. You can choose any of the initial point. The best way how I can choose the two, you can see the root is root 3. Root 3 is nothing but my 1.732, which lies in the interval of 1, 2. So you can choose any x naught in between them. You may choose x naught as a 1.1, you may choose x naught as say 2.0, that's fine. X naught either as a 1.9, x naught as a 1.5, any number in between them. So let's assume I can choose x naught is my 2, and then we will check about all these functions. So let's see, firstly I can try for this part. So if x naught is my 2, what is my x1? x1 is g of x naught. What is that? This is my g. So I can substitute here 4 plus 2 minus of 3, which is 3. This value is my 3. We can find the value of the g2, which is g of x1. So x1 is my 3. So it is 9 plus 3 minus 3, which is 9. Similarly, we can find the x3, which is g of x2, 81 plus 9 minus 3, which is 80, this is 87, and so on. So once you can find, you will see, oh, these are the increasing. So once is it increasing, is it a convergent? No, this is a divergent sequence. Fine. So it means we can never take gx of this. Similarly, if I take this second part, what will happen if I take x naught is my 2? What is my x1 is? G of x1, 3 over 2, 1.5. What is my x2? G of x1, so 3 over 1.5, which is nothing but 2. What is x3? G of x2, so 3 divided by 2, which is 1.5. Similarly, we can find here. So what you can observe, they are alternating between -1 and 2. Does the limit unique? No, because either it's a 1.5 or 2. So again, this is my divergent. So it means the first two conditions are not hold for the gx. We can check for this third case. So once you can do like this way, so once you take x naught is my 2, what is my x1? So half 2 plus 3 over 2. So once you solve, you will get as a 1.7. Now clearly says that it converges to the 1.7320, which is nothing but my root 3. So out of these three, that is the first, second and third, we can clearly say the third is the best choice because it converges to the root. But the question still arises here, why the other two are not working? This is a one counter example. How we can check the value of the gx in journal? It is not always possible we can write the three equations and so on. What criteria we can choose so that g of x will be converges to the given root alpha? So for that we will state the result of the contraction mapping theorem. This theorem will tell you that for what value of the gx, either the first, second, third or many more, will converges to the root always. So for that, this is my fixed point equation, or this is my fixed point. If this g and my g dash are continuous functions and the value of the g is also lies between the closed interval a comma b. There's the first condition. Second condition is, if you find the maximum value of this mode of gx, maximum value of lambda, and if it is less than of 1, that means if you find the maximum value of the g dash and if it is less than of the 1, then this equation has a unique solution alpha, or you can see alpha is the unique solution of, instead of this fixed point we can say f of x is my 0, or you can see alpha is nothing but my root of the equation, and it is a unique also. Second feature is, once that these two conditions satisfied, then the fixed point equation method converges linearly to the alpha. For, remember, for any choice of the x node, you can choose any choice in between the interval a b. Like if you have the interval a 1 comma 2, you can choose any number between them. You can choose 1.03, you may choose as a 1.5, you may choose as a 1.73, you may choose as a 1.99, and so on, for any choice. And once it's a convergent, then we can found the error bound. This is my convergence root. Fine. This is the exact root, and this is my convergent root, and the difference of them will be here, where lambda is the maximum value of derivative. So once we are finding this contraction mapping theorem, we can summarize the results as main point. We will prove each of these. We will prove that. We will prove in this presentation also. So what is the first result is, if you have the sequence of this, it converges to the alpha, then alpha is my root of the equation. Second major point is, once it will be the convergence, then we will apply the condition on the gx so that it will be convergent. Once it is a convergent, then we will prove that this alpha is my unique, and finally we will found the error of this root. So firstly we will prove all these four results. This is my result 1, this is my result 2, 3 and 4. So firstly, if the sequence is convergent to the alpha, then alpha is the root of this fixed point, or we can say it's a root of function f of x is 0. The proof is very simple. What is given to you? What is given to you? xn plus 1 is convergent to the alpha. That is the meaning of this. Xn plus 1 is convergent to the alpha. Now we all know, if xn is convergent to the L and f is my continuous function, what is the meaning of that? Then you can say f of xn is convergent to the f of L. We can apply the same result here. Since g is my continuous function, why? Because by using the contraction mapping theorem, the root g is a continuous function. So once g is my continuous function, then it means we can apply here. Or what is the g of n plus 1? We can see from here, xn plus 2 is convergent to the g of alpha. Now from the equation number 1, from the equation number 2, and we all know, if it is a convergent, the sequence is convergent, then the limit is always unique. So xn plus 1 convergent to alpha, xn plus 2 convergent to this, when it will be the unique? When alpha is equal to g of alpha. So by the definition of the limit, we can see alpha is g of alpha. So what is the meaning of that? What you can say about that? Alpha is the root of x is equal to gx, or we can see alpha is the root of f of x is 0, because this is your target. What your target is? What is the meaning of alpha is the root of this? Your target is to prove alpha is g of alpha. So that's it here. Next we will see what is the condition on the convergence? This is the only convergent, but what is the condition that when you take x equal to gx, it will be convergent? So that condition is, firstly I will tell you, that's the absolute value of this must be less than of 1. That is my condition. So look at the second result. If alpha is the root of the f of x is 0, which is equivalent to this, g is my continuous differentiable. What is the meaning of this? G is my continuously differentiable. It means g is my continuous and g dash is also continuous. That's the meaning of this. In the interval I which contains this root, such that g dash x is less than alpha, then the sequence which you can obtain from this one, then the sequence, that's x0, x1, x2 and so on, is also converges to this alpha, provided the initial value of this x0 what you have chosen is belong to the same interval I. Means if I say x square minus 3 is equal to 0, then clearly says this is my root. So but if I take the interval of this and if I take the x0 is my 2.3, but clearly says this does not belong to here, so then it will not be convergent. We firstly find the interval in which the root lies, that we can use the intermediate property, fine, and then once you know the interval, then you can choose any value. The proof is very simple. What is given to you? Alpha is the root of this equation, which is nothing but my here. Then for the any point x0, if I choose the any point x0, we can find the sequence x1, fine. So this is my equation number 1. Equation number 2, so if I subtract 1 from the 2, we will get here. Now what is the g? G and g dash are my continuous, fine. So which theorem will correlate when you think about here? So you can see g of alpha minus g of x0, if I divide it by, what is that? This is g dash of c, for c lies between alpha and x0. So can you tell me which result is here? This result is, yes, result is called as Lagrange mean value theorem, fine. So we can find the value of this numerator. What is the value of this numerator is? That is my g dash of c into alpha minus x0, where c is my belongs to the alpha of x0 by using the mean value theorem. Now we have seen g dash of x is less than of 1. So what is the value of this? I can say this is a lambda, fine, or less than equal to lambda. So if I take this value here, then I can take the modulus value on the both side. What will happen? X minus x1, which is equal to alpha minus x0 mod value of g dash of c. Now clearly says what is the value of the g dash of c? It is for all x, then its value is my less than equal to lambda, fine. So I can return this number as here. Similarly, if I take the another pair like x2, then the difference will be less than of alpha minus x1. Similarly, we can move on this side. Now if I multiply all these equations, what will happen? Alpha minus x1 cancel, alpha minus x2 cancel, alpha minus x3 cancel, and n will be cancelled. So the result will be from the left hand side, it will be my here. On the right hand side, it is lambda raised to power n, and on this first part, fine. This is one, you multiply them. Now what is the property of this? Lambda is my less than 1. So what will happen if you take lambda raised to power n? It is also less than is 1. So therefore, what is the value of the lambda n as n approaches infinity? Because lambda is my less than 1, so it means this goes to the 0. So now we can take as limit n approaches infinity on the both side. The right hand side is my 0, so it means this value will goes to the 0. So what is the meaning of that? The difference will goes to the 0. It only implies xn plus 1 will goes to the alpha. So what is the meaning of that? The sequence xn is convergence to the alpha, and alpha is the root of this equation. So this will be provided only when this condition hold. So this is the condition for the convergence. So when you can say any iterative method or the fixed point iteration method convergent when this condition holds. Next we will show the whatever the root we have found, that is the alpha is the root of this, it is my unique. That means we have to prove alpha is equal to g of alpha, or alpha is the root of this equation f of x is 0 is my unique. So the proof is very simple. We assume that alpha and beta are the two roots of this equation. What is the meaning of that? Alpha is equal to g of alpha and beta is equal to g of beta. Then what is your target? Your target is to prove alpha is equal to beta, then only it will be the unique. Fine. So now you can hear. So I can subtract them because I need this to be the zeros. What is the meaning of that? It's a g of alpha minus g of beta. Fine. Now I can take the modulus value. Now you can see again I can apply the mean value theorem here, which is nothing but alpha minus beta and g dash of c over this complete mode by using for some c which lies between alpha and beta. Fine. So you can simply say as a equality. Now since g dash, what is the, or left hand side is also alpha minus beta. Fine. So I can take this alpha minus beta here, and this common part is g dash of c is equal to 0. So this is my equality. Fine. Now what is the g dash? So we all know this is my strictly less than 1. So what is the meaning of that? 1 minus g dash of c is can never be 0, because g dash c is can never be equal to 1. So from here what is the meaning of that? That means alpha minus beta is my 0. You can say it is a equality. So what is the meaning of this? If mode of them is 0, what is that? Alpha is equal to beta, and that is our target for the uniqueness. So we can see alpha is equal to beta is the root, hence they have the unique solution. Now the last result is we have to find the error, because xn is convergent to the alpha. So what is the error in between them? That we will found here. So as we have seen, alpha is my exact root. Fine. Xn is my approximate root. So we can write like this way. So again we can see this is we can written like of this as g of alpha minus g of xn, or you can write and similar manner. Now I can add and subtract of this. We can apply this rule. What is the mode of x plus y, which is less than of the mode x plus mode y. I can consider this is x, this is y. Fine. So we can write here. So this is alpha minus xn, this is alpha minus xn. We can take on the left hand side, which is here. So I can found this value from here. Fine. Now since this is xn minus xn minus 1, what is the meaning of that? This is x1 minus x0, this is x2 minus x1, and so on. So in journal we can write in terms of lambda. That means this term is written in this form, again by using the mean value theorem. Now we can combine these two pairs, which can be written like of this. So what is the meaning of that? So that is my the error bound of this here. Now since what is the lambda? Lambda is nothing but my derivative of this, the maximum value of this, which is less than 1. So clearly says whenever this lambda is a very small number, is a small number, what is the meaning of that? Lambda raised to power n will goes to the 0. So once the right hand side will goes to the 0, it means xn will converges to the alpha. So it means for the smaller value of the lambda, the convergence rate will be faster, while for the larger value of this, when you take the larger value of the lambda, then it will be convergence rate is slow. The last remark is, if you have the desired accuracy, like of if you want to find the accuracy up to the 4 decimal places, 5 decimal places, you can write the epsilon here. Then you can substitute this value here. We can find this difference from here. So which you can use as a stopping criteria when you are trying to solve the problem, where lambda is nothing but maximum value of their derivative. Once you know this lambda, once you know this epsilon, we can find the stopping criteria here. So what is the summary is, once you have the fixed point equation, then it converges only when g dash is less than 1. And if it is convergent, then it converges to the root of this function f of x is 0, or you can say it's a root of this fixed point, and the error bound is obtained as here. There are a few remarks and the advantages. The first remark is the iterative method is convergent only if g dash of x is less than 1. Whenever g dash is 1, and here the meaning of this is, whenever g dash of x is less than equal to 1, then the method will converge, but the number of the iterations would be very large. On the other hand, if g dash x is very small, then the number of the iteration will be lesser to the convergence. Whenever mod of x is greater than 1, we all know when you can say mod of x is greater than a, that means x is greater than a and x is less than or minus a, then the iterative process will never converge, it is always be a divergent. The advantage is that we have used the same set, because in this case we only need the initial guess x0. Then it will save your memory and time without with respect to the others bisection and the Regula-Falsi. The round of error is also minimum in this method as compared to this others method. Let's say 4 to 5 examples so that you can understand all the theories well. The first question is, show that the rearrangement of this equation does not yield a convergent sequence. Okay, so what is the meaning of that? If you are trying to find the value of the x from here, which comes to be this one, that means if I write, this is my function x, if I write this equation in terms of x equal to gx as here, then it does not be a convergent. Oh, very simple, because remember, because it's a fixed point, so it will be convergent only when this condition hold. So you can compare this equation with x is equal to gx. What is my gx? This is my gx. Fine. Now we can find the derivative. What is the derivative of this? Is my here. So now you have to find the derivative at the point 1. So what is the derivative at the point 1? So it is minus 1.2. So or you can see the derivative of this x at x equal to 1 is my 1.2, which is greater than 1. So once it is a greater than 1, it is not convergent. So we can see in the neighborhood of this, the value of the g dash is my minus 1.2, which is less than of minus 1. That means if you take the modulus, it will be greater than 1. So sequence does not converge. On the other hand, if you find the value of the x from this case, like of 20 minus 10x minus x cube divided by 6, it may converge. Now in this case, this will be my gx. Then you can find the derivative and then check the value at x equal to 1, whether it's this condition hold or not. Look at this another one. Find the iterative formula for this x is root 20. I can written this as x square minus 20 is 0, or I can say f of x is my x square minus 20 is 0. Fine. So this is my fx. Now here, when you apply the fixed point, you need the initial value. In the last question, you can see the initial value is given to you as a 1, but in this case it is not given. So how you can find? First way, you can choose any randomly, let's say 7, but it may happen that the 7 does not near to this root 20. So what you can do, you can find the interval a comma b. how we can find the intervals? We can use this intermediate mean value theorem. What is that? We can find the f of a, f of b which is less than 0. So clearly says, what is the f of 4? 16 minus 20, so minus 4 less than 0. What is the f of 5? 25 minus 20 which is greater than 0. So it means the root lies between 4 and 5. So that means you have the interval of 4, 5. Then you can choose any of the x0 in between them. Fine. Now the purpose is, because we have to apply the fixed point, so we have to transform this equation into x of gx. So how you can find this x square? This is my f of x is 0. How you can find the value of the x? The first way is you can return the value of x is like here. Second way, you can write this value of as x plus of this. Second and the third. How you can write this value? I can add and subtract of this, you can return here. When it will be convergent? The condition for the convergent is, we will check whether the g dash of x, mod of g dash is less than 1 or not. So what is the mod of gx? It is 1 plus 2x. For any x which lies between 4, 5, the value of that 2x plus 1 always greater than 1. It means it is not convergent. Look about this one. This is my gx. If I take the derivative, it is my 20 by x square. What is the mode of this? Is my 20 by x square. So if I take x is my say 4.1 which lies between them, it is greater than 1. But if I take x is my 4.9, then it is a less than 1. So it is not for all x. So it means it is for some x, for some not. Hence this is again not convergent. Remember, your target is to prove this value for all x in the interval. It is for all, but it is for the sum. If you look about this, then we can find the g dash which is always less than 1 for all the x. So therefore this is my iterative formula work for this case. Same as I explained you earlier. So as we have seen with the help of numerical example, this is always increasing. This lies between 1.5 and 2. So how you can see? If you look about the first example, this is my here. Fine. Okay, firstly you can find the interval. This is my root 3 which is lies between 1 and 2. So my interval is 1, 2. So what is the g dash of x? 2x plus 1. Clearly says whenever x lies between 1 and 2, it is always greater than 1. So this is not convergent. What is the g dash x of the second case? It is minus 3 by x square. So what is the mode of gx? It is 3 over x square. Clearly says when you take x is 1, it is greater than 1 for some x which lies between 1 and 2. So it means this is also not satisfied. If you look about the derivative of this function, then clearly says this is my here. Fine. And clearly say this is less than 1 for all x which belongs to the 1, 2. So hence what is the condition for the chosen of the g is, we have to check in which case g dash of x is less than 1 is my condition for the convergence. Look at this another one. If you have a function of this which you can return in the two form like of this and this, which of these if any would succeed and which one is a fail in the neighborhood of x? So clearly says x0 is given to you 0.5. Fine. So then there is no need of this interval. So the condition is my here. First case, this is my g of x. We can find the derivative of this here. Now for the convergence condition, this holds when it will be less than 1. Firstly, because it is a root, so definitely this number must be greater than 0. Otherwise, it will be the complex number. So what is that? 5x minus of 2 is less than 1. Fine. So when it is a less than 1, what you can say? 5x minus 2 is less than 1. So x is less than of 3 by 5.6. And 0.5 is satisfied this condition. So we can say the iteration process will converge in the neighborhood of 0.5. That means if you start with the x0, 0.5, Then you can find the value of the x1. After substituting here, you will get x1, you will substitute x2, and then you will get as a convergence condition. Look about this second case. When this is my gx, condition for this, which is cos is always less than, now it is my less than 1. So this value is nothing but my lambda. So clearly says this procedure is iteration scheme for all the x in the interval I. So whatever the interval you can choose, it is convergent for all x. Whether you can choose x naught is 0.5, whether you can choose x naught is 1.3, it will always converge. So this is the suggestion you can use as a iteration process. Look at the last example. If alpha and beta are the root of this equation, x square plus ax plus b is 0, then the first equation, how you can form? Can you find the value of the x square from here? It is minus ax minus b. So what is the value of the x from here? Ax minus b over x. So I can return like of this. You can see it is a similar of this. So this is my gx. Then it will convergence at alpha when these conditions hold. What is given to you? Alpha and beta are the root of this equation. So we know the sum of the roots and the product of the root. Now for this case, this is my g of x. Then for the convergence condition, we can find the derivative. Then we can start from here. What is given to you? It is convergent at alpha. So g dash of alpha is less than 1. I can substitute the value of alpha here. Fine. I can return this number as, how I return that? If I multiply them, you will get this number. Now since we need the in terms of alpha and beta, so we have to substitute the value of b. What is the value of the b is alpha beta. So I can return this as here. So 1 alpha will be cancelled. So what is the result is mod of alpha is greater than of mod of beta. So it means this condition, that means this scheme will convergent when this condition hold. Look at the second equation formula. How they can form from here? You can see I can find the value of, I can take the x common. So x plus a is my minus b. I can find the value of the x from here like of this, which is this one. Now again, for the case of the convergent, we can find the derivative. Again, it is convergent at alpha. We can start from here. So we can substitute the value of this. What is the value of the alpha plus beta? I can substitute here. Now again, we need the value in terms of alpha and beta. I can substitute the value of a and b here. What is the value of alpha plus a from here? It is minus beta. So I can substitute here. It is minus beta square. B is my this one. So minus of beta square is nothing but my beta square, which is alpha times beta. So 1 beta will be cancelled out. So you will get as alpha is less than of beta. So once you will take this condition, and once this condition hold, then it will be convergent, otherwise not. Similarly for this. So this is the brief concepts about this fixed point iteration scheme. We will see the next lecture how we can solve the examples, how we can find the root of the equation by using the fixed point equations. Till then, I hope you can like, share and comment on my video. You can share with your friends. Best of luck students. Happy learning.